All right, so today we're going to talk about log graphs and logarithmic graphs if you are looking at your screen. And one of the things that we want to talk about today is we just want to do the baby steps. And so what we're actually going to do is remember some of our log properties, okay? And so when we do these, we just want to take a look at the log properties and we want to try to evaluate these. Excuse me. And so we want to make a t-chart. And so what I'm going to do, my preferred method is to say 10 to the y is equal to x. Now watch my data table, because what I'm actually going to do is I'm going to plug in for y values instead of x values. So for example, when y is negative 1, this is 10 to the negative 1, which is 1 over 10. When I plug in 0, I get 10 to the 0, which is 1. When I plug in 1, I get 10 to the 1, which is 10. And so what I want to do is I want to kind of plot those points. And so you can see my graph is a little too small. So I'm going to go ahead and zoom out. And then what I want to do is I want to go ahead and just plot these points. So at x equals 1/10, which is really small, y is negative 1. So like right here. And when x is 1, y is 0. And when x is 10, y is 1. So this is going to look something like that. And now, what I didn't point out was no matter what number I plug in, I'm not going to be 0. I could plug in really, really small numbers for x. But I can't ever, if I plugged in any other number, my calculator is going to say error. And so we want to remember from today that Ms. Collins told us that logs are exponential inverses. So where exponentials had a horizontal asymptote, logs have a vertical asymptote. And so when we come over here, we want to look at the exponential, and we want to see, just looking at the data table, what happens. So we just want to compare, make sure that I'm not totally crazy, right, Mr. D? This is the right assignment, Mr. Dorofeyev. So I'm going to plug in negative 1, and I get 1/10. And then I'm going to plug in 0, and I get 1. And I'm going to plug in 1, and I'm going to get 10. And you're going to notice the same problem with this graph. It's not quite big enough. So I want to go ahead and shrink it out. There we go. Now when x is negative 1, then y is 1/10, which is really little. And when x is 0, y is 1. And when x was 1, y was 10. So this one's going to go like that. And remember, exponentials had that. Now, what I said in class was that these are inverses. And remember, if they're inverses, the y should become the x. Look at that. And the x should become the y. Look at that. So the domain and range have actually switched places. The difference is, on the left side, here I'm plugging in for y's. I'm still plotting it x comma y, okay? So that's what we want to do, and that's what we want to show when we do the next few graphs. So in exercise 43 to 46, I'm going to do these straight out of your book. We want a graph, and then we want to sketch the graph of this one. Now, if they're inverses, I should just be able to switch the x and the y. So I'm going to do f of x first. So 3 to the x. And sketch means sketch. So I'm going to do a little bitty t-chart right here. And I'm going to plug in negative 1, 0, and 1. And then I'm going to get 1/3, 1, and 3. Look at the numbers, 1/3, 1, and 3. So when I go negative 1, just some numbers. When I go negative 1, I'm at 1/3. When I go 0, I'm at 1. And when I go 1, I'm at 3. So I'm going to go like this. This is 3 to the x. Now, if what we just said on the previous page is true, then this should become my x, and this should become my y. So what I should do is I should now flip these points. So to get this graph, I'm just going to flip these and let them be my x's. And these become my y's. And so now I'm going to plot these points. So at 1/3, I'm at -1. At 1, I'm at 0. And at 3, I'm at 1. Figured out. This one's going to go like this. Now, one of the things your book will point out is that inverses are reflections over the y equals x line. So I should be able to take this dot and mirror it. There it is. I should be able to take this dot, which was at 1, 0, and I should see its mirror 0, 1. So that's what you're doing on 43 through 46. We're just mirroring the option. Now you try 44, and we'll discuss that in class. Next slide. Okay, 47 to 52. We want to find the domain, the vertical asymptote, and the x-intercept. Well, I didn't tell you this before, but you need to know it. All logs have a domain that says that whatever is in here, so if I had log of x, that thing, this x, has to be greater than 0. It can never be 0, because you have a vertical asymptote at x equals 0. So notice out here, you have nothing. There's no up-down shift, but the right-left shift is right here. So let's think back to Algebra 1, Algebra 2, geometry. When we're graphing and we shift, inside is opposite. So this right here really means left 2, which means this is left 2, which gives us that x equals -2 is going to be our vertical asymptote, which means that's also going to give me my domain. My domain is x has to be greater than -2. It cannot be -2. It has to be greater. Okay? So here's my domain, and here's my vertical asymptote. Now I'll do one more just to show you. So what's in here has to be greater than 0. It has to be greater than 0. So that means x must be greater than 1. Since x has to be greater than 1, my vertical asymptote is at x equals 1. So this is very, very similar to rational expressions, okay? Where we said the domain couldn't be something and it became our vertical asymptote. Now we're saying x has to be greater than that. And the reason is all logs have to be greater than 0. You cannot be 0. Okay, so now all you're going to do is describe the transformation. So for example, everything from Algebra 1 is still the same. This is exactly the same as this. Here's the difference. That minus sign means we want to reflect over. We want to flip it over the x-axis. What we're saying is the y values are changing sign, which means they were positive, now they're negative, or they were negative, now they're positive. Now this is the parent function that we're looking at. How would this move my graph? So think about it. Inside is opposite. So this says my graph is going to go left. How many spaces? 7. Okay? So inside opposite. Not plus, but left, negative. Okay? So we're going to use the shortcut method or the cheat method, right? We want to talk about our translations. We want to know what the parent function looks like. And then we want to be able to use those shifts. One of the most important concepts of logs is that logs and exponentials are inverse operations. They are used to undo each other. Okay, so short video today. Here's your turn to practice. So what you're going to do is you're going to take this problem set and you're going to do a couple of them at home. Just a couple. These are like the ones we did in class. And by the time you come in tomorrow, I only want you to be up to number 21. Okay? Only the number 21. Tonight's homework, 1, 5, 8, 15, 17, 21. It's just a couple of calculator practice problems. It is nothing extravagant, okay? Basics problems you can do for homework. All right, Mr. D, I hope you are not confused. This is the correct video. I'm now going to upload it, and I'm going to call it Mr. D, watch this one. All right. Good luck.